Let us see copper saving in auto transformer. Copper used in two winding transformer is more than that of copper used in auto transformer. That's why the weight of auto transformer will be lower than that of two winding transformer. So let us see how copper is saved into auto transformer. So a copper weight I can write as copper weight will be written as copper volume into copper density. Copper density used will be constant. Therefore I can write copper weight is directly proportional to copper volume. This is constant, right? Now what is copper volume? It is volume is just like cross sectional area into length, so I will write it as proportional to copper cross sectional area into copper length. Now cross sectional area, so we know current density which must be constant is given by current divided by cross sectional area through which current is flowing, that is copper only, and it is what? Constant. Therefore I can write cross sectional area is directly proportional to current, and copper length will be decided by number of turns, so it is dependent on number of turns. Therefore I can write copper weight. I will replace area and length by current and number of turns. Therefore copper weight will be written as IN. What is it? And that is mmf only. So copper weight depends on mmf, right? So let me take the transformers. So two winding transformer, that is our conventional transformer. So it has primary and secondary winding. Current is I1, current is I2, number of turns N1 and number of turns N2. So total mmf, if I have to write for this transformer, W2, so total mmf will be N1 I1 and N plus N2 I2, and that will be equivalent to copper weight. So copper weight, that is W2 winding, is directly proportional to total mmf N1 I1 plus N2 I2, right? Now let me take any auto transformer, any that is step up or step down. So let me take first a step down auto transformer. So I have step down auto transformer, say this one. Here current is I1, number of turns are N1, right? Here number of turns are N2, current here is I2. Now current in this portion will be I1 minus I2 downward, or upward I can write as I2 minus I1. What will be number of turns in this portion? That will be total turns minus N2. So that is what? N1 minus N2. So if I have to write mmf, I will write mmf with respect to this winding only. So this winding turns into current through this will be mmf of this portion, and for this portion mmf will be current in this portion into number of turns. So I can write here W auto, that is copper weight, is directly proportional to total mmf. Total mmf is N1 minus N2 I1 plus N2 I2 minus I1, number 2. So divide them. 1 by 2 will give you W2 winding by W auto. Proportionality will be replaced by equality. It will be N1 I1 plus N2 I2 divided by N1 minus N2 I1 plus N2 I2 minus I1. We know N1 I1 equal to N2 I2, and we also know N2 is Kn1. So replace them here. So this W2 winding by W auto will be N1 I1 plus N1 I1. Open it. It will be N1 I1 minus N2 I1. So N2 will be Kn1 I1 plus it will be N2 I2. So I will write that as N1 I1 minus it will be written as N2 I1. So that will be again Kn1 I1. So twice N1 I1 divided by twice N1 I1 minus twice Kn1 I1. So N1 I1 and 2 will be cancelled, and I can write as W2 winding by W auto equal to 1 by 1 minus K. So this implies W auto, copper weight in auto transformer, is 1 minus K times of copper weight in 2 windings. Therefore, what is copper saving? Copper saving will be copper used in 2 winding minus copper used in auto transformer. So that is what copper 2 winding minus 1 minus K W2 winding. So W2 winding will be cancelled, and copper saving will come as K times W2 winding. Right. So this is what copper saving in auto transformer. For a step down, if I take a step up auto transformer, step up auto transformer, then say this is the step up auto transformer. Here a number of turns are N1, current is I1. Here number of turns are N2, current is I2. Downward current is I1 minus I2. Number of turns in this portion will be N2 minus N1. So MMF of this portion plus MMF of this portion will be total MMF. So W auto will be directly proportional to N1 into current in this section, that is I1 minus I2 plus this winding. So that is N2 minus N1 into I2. Now I2 is written as I1 by K. I will replace it, and we know N1 I1 equal to N2 I2. Therefore, W auto will be directly proportional to N1 I1 minus N1 I2 plus N2 I2 minus N1 I2, that is directly proportional to twice N1 I1 minus twice N1 I1 by K. This N1 I1 and I2 and N1 I2 will be twice time, and I2 is replaced by I1 by K. So if I take a ratio of this with 2 winding transformer MMF, which is fixed, so W2 winding by W auto, we know W2 winding is N1 I1 plus and 2I2 divided by twice N1 I1 minus twice N1 I1 by K. N2 I2 is replaced by N1 I1, so it will be twice time N1 I1 divided by twice N1 I1, 1 minus 1 by K. Therefore, W auto will be written as 1 minus 1 by K times W2 winding. So what is copper saving? Copper saving W2 winding minus W auto. So that is W2 winding minus 1 minus 1 by K W2 winding, and it will come as W2 winding by K. So this will be copper saving, right? So this is how we can find the copper used in autotransformer, which is less than that of two winding transformer. Let us see now kVA rating of autotransformer. So for this I will use copper to design. I will use copper of autotransformer to design two winding transformer, and we'll see whether the rating is changing or not. So let me take any one autotransformer, say step up autotransformer or step down. So let me take first a step down. This is my step down transformer. kVA rating, that is VA rating, voltage and current multiplication. So I will focus on voltage and current only. Here supply voltage is V1, current is I1, right? Here voltage is V2, current is I2. In this portion what is current? I2 minus I1. And here what is voltage? V1 minus V2, right? This is autotransformer, and for autotransformer kVA rating S auto will be V1 I1 equal to V2 I2. Now if I use these values to design two winding transformer, I will use this as primary winding and this as secondary winding. So in this portion what is current and voltage, that will be taken for two winding transformer, and this portion will be for secondary side of two winding transformer. So let me draw here two winding transformer, right? So this portion voltage is V1 minus V2. So here it is V1 minus V2 primary, and current here is I1, and in secondary voltage is V2 but current is I2 minus I1. And here if I have to write two winding transformer kVA rating, I can take any side values, multiplication of this voltage and current or multiplication of this voltage and current. So let me take V1 minus V2 into I1, that is V1 I1 minus V2 I1. What is V2? It is kV1, so it will be V1 I1 minus kV1 I1. V2 is k times V1, we know it. Therefore S2 winding can be written as V1 I1 1 minus k. What is V1 I1? That is autotransformer kVA rating. So S2 winding equal to S auto 1 minus k, right? Therefore S auto will be written as S2 winding by 1 minus k. Okay, mind you, it is a step down transformer, therefore k is less than 1. If k is less than 1, then S auto will be greater than S2 winding. So this is how auto transformer kVA rating is greater than two winding transformer. Let us go for step up auto transformer. So step up auto transformer, so this one, current is I1, voltage is V1. Here current is I2, voltage is V2. In this portion, what is current? I1 minus I2. And voltage across this section will be V2 minus V1. And KV rating is same, S auto equal to V1 I1 equal to V2 I2. Now let me take two winding transformer. Here it is two winding transformer. So this portion will be taken as primary, where voltage is V1 and current is I1 minus I2. And this portion is secondary, where voltage is V2 minus V1 and current is I2. So take any side. S2 winding will be V1 I1 minus I2. What is I2? I1 by K. So it will be written as V1 I1 minus I1 by K. Right, where I2 is I1 by K. So S2 winding will be V1 I1 1 minus 1 by K, or S2 winding is S auto K minus 1 by K, or S auto will be K by K minus 1 S2 winding. So as it is step up, K is greater than 1, and if K is greater than 1, this value will be greater than 1, therefore S auto will be greater than S2 windings. So this is how auto transformer KV rating will be always higher than two winding or conventional transformer.